Hi guys, welcome to God Academy. In this live tutorial, I'll be taking you through a series of advanced complex numbers problem. If this is the first time you are visiting God Academy, kindly subscribe and please join the family. Don't forget to share to people who find this useful as well. So I start with the first problem, which says find all z such that e to the power iz is equal to 3I. Find all z such that e to the power iz is equal to 3I. So let's get straight to this problem. Now, we are supposed to find the values of z. It may be value or values, but before you ask yourself, what is z? Z is a complex number, and a complex number is always represented as real parts and its imaginary parts. Maybe purely real parts or maybe purely imaginary parts. So before we start, let's assume that z is equal to x plus iy. If it happens that z doesn't have a real part, x will turn 0. And if it happens that z doesn't have an imaginary part, y will turn 0. So let's first start with the assumption that z is equal to x plus I y. Once this is done, then we can quickly put this back into the equation. So you have e to the power I multiplying my z, which is x plus iy. And this should be equal to 3I. So you have e to the power. Now, we are supposed to simplify. So I multiplying x will give us ix. I times I is -1, so I get minus y, right? Then this should give me 3I. So at this point, we are still not done. We want to compare because for every equality, the term on our left hand side should be equal to the term on our right hand side, right? So for us to do the comparison, we need to get the corresponding terms to be equal. There is a term with I which must be separated, and there's a term without I. At this point, let's apply indices here. You know that if you have any two base which are the same and they have power a and b, this can give us e to the power a plus b. So employing this same principle here, I'm going to have e to the power ix multiplying e to the power -y, and this should give us 3I, right? So once you have this expression, then you know that from Euler said if you have I e to the power I theta, this is the same as cosine theta plus I sine theta, right? So I'm going to employ the same thing here. So at this point, I'm going to have e to the power -y still standing outside, but the e to the power ix, I will convert it to the polar form, giving me cos x plus I sine x. This should be equal to 3I. So at this point, we have e to the power -y standing out, cosine x plus I sine x. Let's see something here. You realize that in polar form representation of complex numbers, you have the general representation to be r multiplying cosine theta plus I sine theta. Is that not it? So if you want to draw some kind of resemblance here, okay, or similarities, you see that r is equal to e to the power -y. So here I'll have my r, which is the modulus, to be equal to e to the power -y. Then we can equate the r here, which is the modulus, to the modulus of the complex number we have here. So the complex number we have on the right hand side is 3I, which is a purely imaginary number. A purely imaginary number, meaning it doesn't have a real part. So the r here, if I'm to find the r here or to convert this to the polar form, right, you realize that I'll have, if I'm to convert this to the polar form, realize that I'll have my r to be simply be equal to square root of what? 3 squared. And that will give me what? Square root of 9. And that is 3. So we can confirm that the r on the right side is 3. And here my r is simply the coefficient of the expression cos x plus I sin x. Therefore, I can perfectly equate e to the power negative y to 3. I hope this is very understandable. So once I have e to the power negative y is equal to 3, then how do I find y? Because y is part of my answer. My answer, I need x and I need y for my answer to be complete. So to find the value for y, I have to apply the natural logarithm, right? So I'll take ln e to the power negative y should be equal to ln 3. Okay, so if you have ln e to the power negative y, then obviously you know that you're going to have negative y as a result. So natural log of a number e, we get the power. This should give me ln 3. Therefore, my y is simply equal to negative ln 3. So this is the value for my y. I reserve this. How do I get the value for my x? How do I get a value for my x? So this is where we reached. We first equated e to the power negative y to 3. How do I get a value for my x? You can clearly see that x here is the argument of the complex number on my right side. So after expressing this right hand side into the polar form, the r becomes the same r here and its argument becomes the same argument here. So if you have a complex number I, what's the argument? On the Argand diagram, realize that right on the y-axis, I have my positive imaginary number and I have my positive real number on this side. So my I falls here, right? And therefore, its argument is 90 degrees from the positive real axis. So it is 90 degrees from the positive real axis. Therefore, I'll say that my argument is simply pi on 2. But for extended arguments, I'm going to have pi on 2 plus 2 pi k, right? So I can say that I have here to be 3 multiplying cosine of the expression pi on 2 plus 2 pi k plus I sine pi on 2 plus 2 pi k, right? So that is it. So now you can clearly see that the argument which is equal to x on the left hand side will be equal to pi on 2 plus 2 pi k. And that is it. So now I have my x, I have my y. What is the value for the value? What's the value for the variable z, which the question asked initially? So it is simply going to be z is equal to my x plus my iy. And now my x is pi on 2 plus 2 pi k plus I multiply my y. And what's my y? Negative ln 3. So this finally gives me pi on 2 plus 2 pi k minus I ln 3. And that is all. So this is how we solve or we go by problems like this. Anytime you've been asked to find the values of z, just first make z be equal to any random arbitrary complex number, insert it into the right equation, then after you solve to find the respective values x and y. Now let's go to the second problem. So it says that write in Cartesian form a plus ib, where a and b are real, and simplify it as much as possible. So you realize that we have real here, which is a key word for us to look at. We also have the Cartesian form a plus ib. So we are just to convert the complex number into Cartesian form, right? So let me write a complex number here. I think it wasn't captured, which is e to the power 2 plus I pi on 3. So this is a complex number, and we are supposed to express this in the form a plus ib, right? So solution, have e to the power 2 plus I pi on 3. How do I express this into a plus ib? I know somebody will be tempted to go and use lane, right? But before you use lane in complex numbers, please take your time, analyze the problem very well, and see if it is solvable without natural logarithm. Unless it is not solvable, that is when you apply natural logarithm. So the first step is decomposition. Decomposition. So learn to decompose before you go through the hell of finding the natural log on both sides and all those stuff, right? You are just to express this from one form to the other. So if I want to simplify this, then it means that I can decompose this expression to e to the power 2 multiplying e to the power I pi on 3. As simple as that. So this first step is not difficult and it's relatable. So with this, I can go on. This now is just a number, right? E squared is just a number. But here, it is a complex number because of the presence of the I. The I shows that it is a complex number. So what is the complex representation of? So this is the polar form. So we need to break it down to the Cartesian form as the question asks us to. So this will give us cosine of the expression pi on 3 plus I sine of the expression pi on 3. Then you close bracket as it is. So with here, we are going to have e squared still standing out, multiplying this. What is cosine pi on 3? And remember, pi is 180, right? So 180 over 3, which is 60. Okay. So you just simply find what cos 60 is. You just enter the value for cos 60. So you put that into the calculator. That will give us a perfect half, right? Half. Then we come here plus I. What is sine? So here to the same thing. 180 over 3, which is 60, right? What is sine 60? So sine 60, which is root 3 out of 2. Root 3 out of 2. So I have root 3 out of 2 nicely. So at this point, you can clearly see that I'm approaching my answer because the answer said you should leave it in the form A plus IB. And it said it should be simplified as much as possible. So let's keep on simplifying this. So I will get, now you can see I have a factor out. So I simply have to multiply. So this will give me e to the power 2 over 2 plus e to the power 2. Maybe I can push my I out here. Square root of 3 all over 2. And this is perfectly my answer. So what is A? A is simply equal to e squared out of 2 and B is simply equal to the coefficient of I, which is e squared square root of 3 all out of 2. And that is simply the answer for this problem. At this point, if you have still not subscribed to this channel, kindly do so by subscribing because we're going to offer you services like this. So you'll be seeing some real life tutorials like this. Please share as well. So let's go to the third problem. It says find the real parts of. So find the real part of the expression, which is a complex number here, where x is real. You are supposed to find the real part of this complex number, right? So e to the power 5 plus 12i multiplying x. Find the real part of this. So this problem mostly show up in the exams a lot. So kindly take note of that. You'll be given sometimes very weird expressions for you to find just the real part of that expression. Or sometimes you'll be asked to find the imaginary part of that expression. So to find the real part of this expression, we need to decompose as usual. I said don't be tempted to use natural logarithm until you found that you cannot do anything to the expression. And that is when you find the lane, right? So problems like this where you've been asked to find a real part, don't just go apply lane. Going to just waste your time. So at this point, what do? You have to simplify your expression. So the expression here is not simplified because you have x still standing out. So x is real number. So as the problem already stated that x is real. If x is real, then it means that it's just a number. But if x was to be a complex number, it means that we would have also find a complex representation. So please take note of the nature of the questions. So here you have e to the power 5x plus 12ix. 5x plus 12ix. So this is the first step. Now you've simplified. After this step, what are you going to do? Decomposition. Decomposition. Remember that for every polar form representation, there's I. So if you have a term without I, then you can easily kick that off outside the complex zone. So I'll just have e to the power 5x multiplying e to the power 12ix. So at this step, what are you going to do? I need the real part, only the real part. So I need not to solve plenty. I just have to focus on how to get the real parts. But remember that e to the power 5x, since x is a real number, it means that this whole part is a real part, which I don't even have to bother myself simplifying again. So that is e to the power 5x remains. And this expression here is a complex number in its polar form. So I can actually break this down and let's see. You have this to be cosine of the expression 12x plus I sine of the expression 12x, right? So now what follows? You have to simplify. So simplifying this, you have e to the power 5x multiplying cosine of the expression 12x plus e to the power 5x multiplying I sine of the expression 12x. So at this point, it's clearly that this is a real part and this is the imaginary part, right? So this is our answer. Therefore, our answer is simply equal to e to the power 5x cosine of the expression 12x, like this. So this is the answer, right? This is the answer. Let's move on to the next problem. Good. So question number 4. You say simplify 2I multiplying the expression I minus 1 plus the expression which is a conjugate, right? So see, it is a cubic function, right? So a cube of the expression which is a conjugate of the complex number root 3 plus I plus two other expressions multiplying where we have 1 plus I multiplying its conjugate. So let's see how we can simplify this expression. So you realize that the only problem we have with this problem is this. The only problem that we have with this problem, yeah. So you realize that this part is just the problem. If you're able to simplify this, then I think the whole work is very easy. But how do you break this down? So that makes it a little bit advanced, I would say. So solution, I'll have 2I multiplying I minus 1 plus root 3 plus I conjugate cube plus 1 plus I 1 plus I conjugate. Now, let's break this problem into three different parts. We have part 1, we have part 2, and we have part 3. Three parts. So let's solve them differently, independently. So for the first part, I'll have 2I multiplying 1I minus 1. So this is simple. 2I, you know that I times I is negative 1. That'll give me negative 2, right? Then you know that I have 2I times negative 1. That will give me negative. That is for the first part. Now, let's go straight to the third before we come to the middle one. So for the third part, so let me circle this as my answer for the first part. Good. Now, for the third part, I'll have 1 plus I multiplying its conjugate. And you know that in complex numbers, when you say conjugate, it's simply negating the imaginary part. So that would be 1 minus I. Is that not it? So here we simplify. 1. So this is like difference of t squared apparently. So you let's solve. 1 times 1 is 1. 1 times negative I is negative I. Positive I times 1 is positive I. And I times negative I. That is a problem. You know that I times I itself is equal to negative 1. Therefore, I times I, negative 1 times negative 1, which is positive 1. And obviously, you can see that these two can cancel easily, right? So once that these two cancels, I'm going to get 1 plus 1. So for my fourth, sorry, for my third part, I had answer to be what? 2. Now let's move to the middle part, which is the end of all. So I have the expression square root of 3 plus I conjugate cube. So before I start, I need to clear off my conjugate. That will give me square root of 3 minus I. So everything here cube, right? Good. So this is where I have to continue from. Now, you'll be tempted to use um the Morvis term here. Please, in complex numbers, we don't really use the lane and the De Morvis term and the rest like that. A power like 3 and such a question, you have to go straight forward and simplify. But one will say that, I mean, cube to find a cubic and whatever is something complicated. So you can easily break this down and you can get something like square root of 3 minus I squared multiplying square root of 3 minus I. And this is the same as what you have here. So once you do this simplification, you realize that I'm squaring this, right? So when you square root 3, what do you get? You get 3. Then you know the format, right? So it will be minus 2 I root 3. Then this will give me what? This squared. That'll be what? The negative squared will be positive. Then the I squared will give me negative 1. Like this. This will multiply square root of 3 minus I. So at this point, I'll have 3 minus 1, which is 2, minus 2I root 3, like this. And this will equally multiply root 3 minus I. So let's simplify this expression starting from here. So 2 times root 3 is going to give us 2 root 3. 2 times negative I will give us minus 2I. Minus 2I root 3 multiplying root 3. So the root 3 and the root 3 multiply to give us what? 3. And now multiply these two, we get minus 6I. As simple as that. Then finally, minus 2I root 3 times negative I. So the minus and the minus will first give us positive, right? Then I times I will give us negative 1. So our answer will be minus 2 root 3. As simple as that. So you can see that the minus 2 root 3 and the 2 root 3 here can go home, right? The 2 can go. Therefore, this will just find its way out. And I'll have negative 2I minus 6I. And that is what? Negative 8I. As simple as that. So now, let's come back to our problem. We have negative 2 minus 2I for the first part. Then I have for the second part minus 8I. Then for the last part, I have plus 2. So how do I solve? You know that plus 2 can go away with this plus 2. And what is my answer? My answer is simply minus 10I. And that is all. So in simplification, just don't stress yourself doing things which will waste a lot of your time. Just break it down. Something like cube, I said you can just simplify. Unless the question says that find the root or find all the, I mean, values of z, for which those type of questions fine. But here you've been asked to find the cube of this expression. So that is one thing you have to take note of. So we continue. So again, if you haven't subscribed, please do well to subscribe, support the mission. So this is our fifth question. So for this problem, it says find all the solutions. Find all the solutions of z to the power 5 is equal to 6i. I think this problem is a little bit familiar. So find all the solutions of z to the power 5 is equal to 6i. What do I get? My z will be equal to 6i to the power 1 out of 5. But before I go here, the first step is to convert this 6i to polar form. Whenever you're about to find the nth root, so this is under what you call nth root, which is an application of De Moivre's theorem, right? So to find the nth root of any complex number, make sure that you convert the complex number to polar form. So what is 6i? 6i on the Argand diagram is very simple. You draw and you locate 6 on this plane. So on this, that is all. So this is where you can find your 6i. So if you draw your 6i from the origin, you know that your magnitude is simply 6. Is that not it? Then your argument is going to be 90 from the positive real axis. So it is very easy for us to continue. So I have z to the power 5 is equal to, this becomes 6 e to the power, the angle is 90, so we say pi on 2. Okay, so we have I out pi on 2. But one thing to notice, whenever you've been asked to find the nth root, you apply the extended argument 2 pi k for different revolutions around the Argand diagram. So once you have something like this, then I can come here so that my z is simply equal to 6ei pi on 2 plus 2 pi k all to the power 1 out of 5, right? So c is equal to 6 to the power 1 out of 5 multiplying e to the power, then you can simplify all this inside. So 2 times 2 pi k is 4 pi k. So I'll simply have I out, I have 4 pi k plus pi all over 2. I still have my 1 out of 5 here. So this gives 6 to the power 1 out of 5. E to the power I. Remember, you just multiply. So my expression becomes 4 pi k plus pi all over 10. And at this point, you can get the different values of our complex number z when k is equal to 0, 1, 2, 3, then 4. So this will give rise to all the 5 values you are going to look for. Is that not it? So here, our r remains the same throughout all the values. So for z1, z2 to z5, the r remains 6 to the power 1 out of 5. Then the theta, right, which is the argument, will change. When theta is 0, when k is 0, what happens? Everything here goes away. I have pi on 10. I have pi on 10 as my first argument. When it is 1, I'll have 4 pi plus pi, which is 5 pi on 10, and that is going to be pi on 2. When it is 2, I'll have 8 pi, that is 9 pi on 10, right? Then when it is 3, I'll have 12 pi here, and I'll have 13 pi on 10. When it is 4, 16, 17 pi on 10. Then that is all. So this is how you find. So this is the r and this is the respective argument. You can find all the 5 possible values. As simple as that. Let's go to the 6th problem. So the sixth problem says that find the raw parts of. So this is a very simple, nice application of the Move's theorem. So solution. So I have cosine of the expression 0.7 plus I sine of the expression 0.7 all to the power 53. So with this, by the Move's theorem, what do you do? It's so simple, right? So the Mover said if you have any complex number expressed in its polar form, and you can see this is a perfect polar form because we have the cosine and we have the sine. Then if it is raised to the power n of any value, then the answer is simply you multiplying your argument here by the n, and that is all. So we simply get cosine of the expression 0.7 times 53 plus I sine of the expression 0.7 times 53. So what's the answer? Cosine of the expression 0.7 times 53. 0.7 times 53. That is 37.1 plus I sine 37.1. So cosine 37.1 is 0.797. So I'll say 0.798 plus sine 37.1, 0.603. So I 0.603. So at this point, the problem said we should find the raw part. So the raw part is simply 0.798. Okay. Question 7. Before we finish it up, please, if you haven't subscribed, do well to subscribe this channel so that you get updated anytime we start live tutorials like this. So write in algebraic form, z is equal to I to the power 5 plus I plus 1. That is the first one. Then you have the second, which is 3 plus 3I to the power 8. You have to express in algebraic form. So algebraic form is simply A plus IB. Okay, this is the algebraic form they are talking about. So considering the first one, z is equal to I to the power 5 plus I plus 1. We just come here. You know that I times I, which is equal to I squared, is given as -1. Is that not it? Yes. So if you have I to the power 5, I can say that this is the same as I to the power 2 times I to the power 2 times I. That alone gives 2 plus 2 plus 1, 5. So I have decomposed this, right? Plus I plus 1. Now this is -1 times -1 times I plus I plus 1. So -1 times -1 is +1 times I is I plus I is 2I plus 1. As simple as that. As simple as that. So these are some kind of bonus questions you see, and you don't have to make any mistake to get them wrong. So finally, we have W is equal to 3 plus 3I to the power 8. So to solve this, what's the first thing to do? So this power 8 here, you cannot say that you're going to break this down 8 times. You suffer. So what do? You simply have to express this as a polar form. So as a polar form, I'm simply going to get, now my r is going to give me 3 squared plus 3 squared. That is square root of 9 plus 9, that is 18. So root of 18, which is 0 root 2, right? So this is my r. My theta is simply equal to tan inverse of 3 over 3. So that gives tan inverse of 1, and that is pi on 4. So you come here, have W is equal to 3 root 2, right? Then cosine pi on 4 plus I sine pi on 4, the power 8, everything. So I have 3 root 2 all to the power 8. Then cosine of the expression pi on 4 times 8. So 8 times pi on 4 plus I sine pi on 4, 8. So this gives me 3 to the power 8 multiplying 2 to the power 4. Because this is square root, so the 2 will cancel the 8, I get 4. Then this gives me 4 goes into itself, 1 goes into, so cos 2 pi plus I sine pi. So what is 3 to the power 8? So we have, mostly you don't really have to stress yourself writing the actual values of. No, this is 16. What is cos 2 pi? That is cos 360, right? Cos 360 is 1 plus what is sine 360? 0. So my answer is 3 to the power 8 times 16 times 1. And the answer is 3 to the power 8. So this is the end of our question series. And this is just the first live tutorial. So don't forget to subscribe. I'll see you in the subsequent live tutorials. Please turn on the notification bell and you get notified anytime a live tutorial is started or a new video is uploaded. See you.